Right, welcome everybody to the first Pipeline conference. So I was kind of pleased when I was asked to give this talk. I talk about continuous delivery from time to time at various conferences and so on, but I thought being asked to do the keynote at a conference like this, I'd try and do something a bit different. So rather than talk about the how-tos, I want to talk about the whys. So why do we do continuous delivery? Why does it work? That kind of thing. So that's really what this talk today is about. I can get my thing to work, which it's not. Okay, so what's the state of software development? This is a very debatable case, and part of the reason why it's so debatable is it's so hard to measure software projects. If you're going to measure, try and figure out whether your software project is doing better than my software project, we've got to level, if we're going to be at all scientific about this, we've got to level all of the variables. Are we developing the same software? Is the team have the same skills? Are we using the same tools? Is the environment the same? There are so many variables that it's really very difficult to do. So first of all, I am going to show you some numbers and some statistics from various surveys on the software industry and the state of it, but take them with a pinch of salt, because it's very hard to measure this stuff. But still, there's kind of a theme to these things. If you look at these things at all, there's kind of a theme, and the theme is that generally, software development, we're not very good at it. I particularly like this one, or rather dislike this one. In a study of 5,400 large-scale projects of greater than $15 million, 17% of projects go so badly that they threaten the existence of the organization. That's pretty terrifying. So if we're talking about the state of the software industry, I would kind of say it's not really fit for purpose. A lot of what we've done and a lot of the approach that we've applied over the years kind of hasn't worked out quite so well. But I think there's cause for hope. I think things are improving. So what have we tried? So we've tried kind of adapting processes from other industries. So we've assumed that this was like a production line, and we kind of copied Henry Ford's model of dividing things up and doing little pieces separately and throwing bits over the wall from one part of the organisation to another. And waterfall processes, if anybody's old enough to remember the V model. Siloed organisations as kind of being part of the norm of that. We started to look at other approaches, and there was kind of probably in the mid-90s, early 90s, the RUP and things like that. And actually, RUP has a terribly bad name because it was really a kit for building processes, and you could build horrible processes as well as you could build good processes. But there were some decent things in it, and actually, if you look at what the people that invented it were really talking about, they were trying to promote some decent ideas, sort of iterative approaches to development and so on. We tried extreme programming. We tried hiring really smart people who were grumpy and put them in the corner. We've tried hiring lots of young, smart people because they were cheaper. We tried hiring lots of young, smart people from other countries because they were even cheaper. And kind of none of this really worked very well. Although some of it started to get a little bit better through some of those approaches. What do we really want? What we really want is we want to shorten the gap between having an idea and getting it into the hands of the users. Everybody that has any relationship with software really wants that. That's what the business wants. That's why they've been disappointed in us for decades, because we haven't delivered on that promise. We haven't been able to quickly realize their ideas and try them out in production. Mostly through the history of our industry, that's not what most software projects have looked like. They haven't been quick, cheap, and reliable to deliver ideas into the hands of users and get feedback. Instead, they've been slow, inflexible, and expose risk late, which is a terrible idea, because when you expose risk late, you're reacting, you're going to be on the back foot all of the time. It's going to be a much less efficient process. Can I try one of your remotes and see if it works with my thing? Because I think the battery. Okay, doesn't matter. It's fine. Doesn't matter. Okay, so I want to pose a question. What's the most successful invention in human history? Any thoughts? The wheel. That's not a bad invention, I suppose, but fire or the internet. I would both good things, both very nice to have. But I would argue that no, you're wrong. Science is the best invention in human history. If you think of nearly all of the advances of the last 2 centuries, they're fundamentally down to the application of science. And I'm not talking about Large Hadron Colliders and gene therapy. What I'm talking about really is a really simple idea. It's the scientific method. It's the idea of being iterative, experimental, and not trusting our guesses. And if you start to apply that sort of thinking to hard problems, it tends to work. It tends to make things more efficient, more effective. So what am I talking about when I'm talking about the scientific method? This is just something, this is, as all good speakers will do, this is my quote from Wikipedia. So scientific method, characterization, make a guess based on experience and observation. So look at the problem. Hypothesis, propose an explanation for that problem. Deduction, make a prediction from the hypothesis so that you can verify your hypothesis and then test the prediction. And iterate. And iterate is a vital part of the scientific method. That's how you get progress. Not by assuming that you're right, but actually by assuming that you're wrong. And proving when you're wrong with the experiments and moving forward on the basis of what you learn from those experiments. Given the audience here, I guess this is probably familiar to many of you, the Deming cycle. Edwards Deming was a process person who revolutionized Japanese industry after the Second World War. And he was kind of the founder of moves like lean manufacturing, total quality management. Those ideas were really kind of grounded in the work of Edward Deming. And one of the things that he did was he came up with this idea for designing processes. Plan, do, study, act. Plan, do, check, act, depending on which version you read. And really, this is a direct lift from the scientific method. It was a conscious lift on his part to pull those ideas from the scientific method and apply them to process. And as I say, it kind of revolutionized Japanese industry. For those of you, and I can see that there are several of you in the audience that are old enough to remember the dominance of Japanese economy in the 80s and 90s, this was part of the reason why, is because they were applying these sorts of principles and they were just much more efficient at running their industry than most of the countries in the world. So what do the numbers say? So what actually works? So this is back to software again now. So we're talking about software development. So there's the Chaos Manifesto is a long-running annual analysis of the state of software development. And it's been going for a long time now. And is reliably depressing when you read it. You can look at the data, and there's lots of people that question this data, as I said before, and I'm not going to defend it, but this is what their numbers say. So for waterfall projects, 57% of them are challenged, 29% fail, and 14% succeed. Agile projects are better, but not lots better. So 9% fail, 49% are challenged, 42% succeed. At least we kind of upped the number of successes a little bit with Agile development. There's another alternative, slightly more optimistic analysis. This is performed by Scott Ambler, who writes for Dr. Dobbs and is an IBM research guy in the field of Agile development. And he says that Agile development projects, 64% successful, Lean 72% successful, Iterative 65% successful, ad hoc processes, that's kind of people just winging it and do whatever they like. 50% successful, which is better than waterfall, which is about 49% successful. I've kind of arranged these as well. So the top line, you can see there's a little bit of a trend. So the top line looks quite a lot better than the bottom line in terms of the success of these processes, the approach. And I would argue that's because they're tending towards the application of the scientific method. They tend to be iterative. They tend to be looking to verify the steps as you go through. That's a characteristic of agile software development. So lean looks pretty good. Sorry, just stepping back. Lean looks pretty good. That's actually got the highest number. So what's lean about? So lean thinking is really about delivering fast, making sure that you're building a quality product, optimizing the whole process, not just some small element of it, eliminating waste, and there are various types of waste to focus on in software development, amplifying learning, make sure that your organization is continually looking to improve and get better, make decisions late in the process because that way you're going to have the most information at the point at which you make your decision, and empower the team. The people that are actually doing the work are the people that know how to solve the problems that they face. So the other way of looking at that is that the people that cause a mess should be able to fix it, should be in a position to fix it. So what really works? So what really works is if you apply the scientific method, I keep talking about this iterative thing, it's all about establishing feedback cycles. As human beings, what we're terrible at is predicting the future. We're just hopeless at it. What's really good at predicting the future are things like maths. That's what works. And so we need to be a little bit more rigorous in our approach. And the way in which we do that is we minimize the time horizon, our exposure to risk that our guesses place upon us. So we try and make sure that we establish effective feedback loops at different levels of granularity to inform us of the quality of our decision making. So in a software project, that kind of happens, it's like layers of an onion, it happens at different levels of granularity. In the inside loop, there's a very quick feedback cycle. If you're doing test-driven development, it's probably in the order of about 15 minutes. You're going to write a test, you're going to see that test fail, you're going to implement the code that makes the test pass, you're going to see the test pass, you're going to commit, you're going to move on to the next. So that's kind of one level of feedback loop. But the other one that's vitally important, that's crucial to our interaction with the organizations and the value that we deliver to them, is the outside one, is that feedback loop that we were talking about earlier, from somebody having an idea, getting that idea into the hands of some users, and evaluating the quality of that idea, seeing whether that's an effective idea or an ineffective idea. One of my, as you can tell from the tenor of this talk, I'm a pop science nerd, and one of my great heroes is Richard Feynman. If you don't know anything about Richard Feynman, I recommend that you look him up. One of the most fascinating individuals of the 20th century. A brilliant mind, an interesting man, an accomplished bongo player, and the world's Western expert on tube and throat singing. A very weird guy. But he was and a Nobel physicist. I probably didn't mention that, and that's probably kind of crucially important. He worked on something called quantum electrodynamics, which is the most accurate theory in physics that human beings have ever come up with. The predictions of quantum electrodynamics are more accurate by orders of magnitude than anything else that we've ever invented. Much more accurate than Einstein's work. Not saying that Einstein was bad either. But my favourite quote from his: it doesn't matter how intelligent you are, if you guess and that guess cannot be backed by experimental evidence, then it's just a guess. So, if we want to try and avoid guesses, we need to get a bit more thorough. We need to establish our feedback loops. We need to question our thinking. We need to be skeptical about the assumptions that we make, and we need to try things out. One of the ways of pushing you in the direction of getting better feedback loops is something that Jez and I mentioned in our book, so thinking about the cycle time of your projects. And the cycle time is an idea that was first introduced by Mary and Tom Poppendick, and the idea is if you think of the smallest change that you can make to your software, how long would it take you to get that change into production, into the hands of users, following your normal process, doing all of the verifications that you should and would normally do? And for many traditional project process organizations, that cycle time can be in the order of months. I once, when I was a consultant, worked in a bank, and the smallest change that they could make would take them more than 6 months to get into production. When you have a cycle time like that, you really effectively got no feedback loop. You're not being able to see the results of your experiments, your ideas. At that point, something gets released into production, they come back to me as the guy that developed it and said, what do you think you were doing? This isn't working. I say, I have no idea. That was 6 months ago. I'm in my 50s. I can't remember what I was doing last week. I'm not going to go into the detail of the breakdown. For this particular project, it's just something that I lifted. But this is a cycle time that I kind of did pick out, and this was actually one that I picked out from a project that I worked on. And for here, our cycle time was in the order of about 57 minutes. So any change, whether that was a single line change, a change of the version of the language we were using, a change in the database vendor that we were using, anything, if it went through the pipeline and all of the tests passed, it was ready for production, and we would know that answer in about 57 minutes. Now that's a feedback loop that you can work with. That's useful information. You might need to go away for a cup of coffee while you're waiting for the results of that, or be working on something else, but it's going to give you information while the work that you did is still fresh in your mind. And that's important because we're fallible human beings. We're not great at holding complex detail in our heads for a long time. So what's continuous delivery about? Why is this relevant to this? Well, I confess, when Jez and I wrote our book about continuous delivery, this wasn't probably in the forefront of my mind, although as a popular science nerd, it influenced my thinking. But the more that I've thought about it since, the more it seems to me that the reason that continuous delivery works is because it's kind of the application of the scientific method to the way in which we deliver software. And the principles kind of that I'm going to go through sort of are aligned with that. At least it seems so to me. So first, it's the first principle of the Agile Manifesto, and that's our highest priority is to satisfy the customer through early and continuous delivery of valuable software. So that's kind of getting back to this idea of making sure that we can have a reliable feedback loop from idea to value in the hands of customers. I'm having an interesting debate with a few people on Twitter over the last few weeks about continuous integration. When we were writing the book, and Jez and I, we hadn't thought of the title of the book, I was a bit frustrated because I thought that what we were describing was really continuous integration. Damn, they stole the name. Continuous integration is great, but continuous delivery is kind of the extension of that. It's the logical extension of that, from idea to value in the hands of customers. And that's the real important feedback cycle. That's the real value. And so it's kind of the extension of continuous integration in that sense. To be fair, I was relieved when we came up with continuous delivery because it's actually a better name. It's a holistic approach to software development. So a lot of the talk about continuous delivery, a lot of the stuff that's written about it, focuses on a few areas. It talks about the technical details of build pipelines and so on, and how you write tests and all that. And all that stuff's important, but really, if we're trying to get these interlocking feedback loops in place, we need to think about all of them. So it's also about the way that requirements feed into the process. It's the way that those feed into development and inform the testing. It's the way that operations work with developers. It's about the whole software life cycle. We're trying to get to be able to a position where we can make changes into production that are being verified. We're trying to make sure that our thoughts are verifiable. And so we're trying to design our experiments, we're trying to observe the results, and we're trying to do that across the whole value chain of software development. So it tends to impact on all aspects of the software development organization and all aspects of the organization where the business touches that. And in modern organizations, that's pretty much all of the organization. That's a big chunk of what most companies do these days. Every commit creates a release candidate. So this is the idea that, at its foundation, what we're talking about is every time we make any change that's going to end up in production, if we're lucky, we're giving birth to a release candidate, and we want to evaluate that release candidate in the context of all of the other changes and see whether they're going to work when they get to production. It's a kind of a good little mental exercise to think of it that way, and it's a good way to think about what the pipeline's about and the level of validation and verification that you want to apply through that process. And finally, I've kind of probably done this to death, and somebody once picked me up on this. This is what actually says in the book, but they were quite correct in picking me up. Finished means released into production? Not quite. Finished means released into production and in the hands of its users, delivering some value. Until it's actually doing something useful, you're not done. And even then, you're just starting the next loop of the iteration. So we're trying to create a repeatable, reliable process for releasing software. And if we're going to do that, we've got to minimize the degree to which we, fallible, human, meatware creatures, are allowed to tinker with it. We're just not repeatable and reliable enough, so we've got to automate almost everything. We need to automate these processes. Computers are wonderful at doing technically complex, boring tasks perfectly, once you've set them up to do them perfectly once. We are terrible at that kind of thing. We kind of wig out halfway through. We go off for a cup of coffee and forget where we got to. And I'm particularly fallible in this respect. I'm much worse than average, but even the best of us are nowhere close to as good as a machine at doing these sorts of things. So use the machines for what they're good at. Use people for what they're good at. If we're going to automate almost everything, then we need to version control almost everything. You can't have guesswork and flexibility when we're looking at an automated process. So we need to be very, very rigorous about knowing which bit and byte, or every bit and byte that's going to make it into production. And that doesn't just mean the source code of our software. That means the configuration of our systems, the database schemas, the configuration of switches, the infrastructure as code. All of those ideas kind of come down to this. It's really trying to be certain about what it is that we're going to release into production, and we're going to be evaluating our changes in that context, so that by the time our changes make it into production, we're pretty damn sure that they're going to work. Software's weird. Mostly in human experience, if something's painful and difficult, it's not a bad idea to kind of shy away from it and ignore it. If you do that with software, things get worse, not better. If something's difficult and painful, the answer is not to hide from that problem. If your release is really difficult and hard and you do it once every 6 months, the answer is not to say, it's really horrible, let's do it every 12 months instead. The other way around is the answer. So if you're releasing every 6 months, start releasing every 3 months. If you're releasing every 3 months, start releasing every month, every 2 weeks, every week, every day, every hour. That pressure improves the process. It forces you to concentrate on these other things. It forces you to automate the process, and it forces you to make sure that it's reproducible. And that's important, because when things go wrong, when you're in the middle of a production incident, you don't want to be winging it. That's the time when you really want to be applying your processes. That's the time when you want to be as thorough as you can be to make sure that you don't make the situation worse. And so making sure that your cycle time is as short as possible, in the region of minutes rather than anything else, That's a good thing, because in that circumstance, when the shit's hit the fan and you're in the midst of a production incident, you can evaluate your changes and be confident that they're likely to work once you get into production. I've kind of talked about some of these others. That I guess the one that the two that I'd like to pick up are the last two. The quality thing's important. I mean, this is a difficult one, and it's a subjective judgment how much you concentrate on quality through the build process. I have no scientific evidence to back me up, but I'm a complete believer that if you focus on quality, total quality, make sure that you really concentrate on the quality of your software. That's not only higher quality software that's an output, it's also more efficient over a long span of time. This is one of those nasty things that kind of plays to our baser instincts as human beings, where it doesn't feel like that. It feels like cutting corners and rushing stuff into production is the quicker route. Over a span of time, I'm convinced that that's not the case. If you work on high quality, you get faster and faster and faster as you learn and improve your processes and your techniques. The last two I wanted to talk about is everybody's responsible for the release process. Everybody has a stake, and so making sure that we provide visibility into that process and transparency is a vital part of this, to make sure that everybody's both engaged and informed and are able to question the decision making that goes on. And you can't apply this kind of process without building a culture of continuous improvement. All of the teams that I've worked on that have applied these kinds of techniques were very, very critical of themselves and their processes. And that was kind of just a natural part of the team. They'd always be looking for holes in what we were doing and ways to improve, ways to go faster. And that's how you get part of the acceleration. And it's part of that engagement and enablement of the teams, making sure that the people that are ultimately responsible for the changes that are going into production are on top of those things and are going to make that work as effectively as possible. So, some of the practices of continuous delivery. There are some more pictures coming. I'm just on a dead bit at the moment. So, build binaries only once. We actually perform any task only once. What we don't want to do is that we don't want to redo things. So we don't want to build our software to a particular target. If we're going to deploy it into test environment 1, we don't want to rebuild it in order to do that. We want to build the software once, and if that software is successful in its adventures through the continuous delivery deployment pipeline, then that's the software that will get released into production. So we're absolutely certain that the stuff that we release into production is the very same stuff that we tested and verified through the rest of our process. We want to use the same mechanisms to deploy our software so that by the time it comes to the point of releasing our software into production, we've already rehearsed this software, this version of the software, with this version of the deployment tools in realistic scenarios. So we know that at the point at which we push the button to release our software, or a robot pushes the button to release our software, it's just going to work because it's already worked. Smoke testing the deployment. An important part of this thing, we are going to get things wrong. Just because I'm talking about being more scientific, being more thorough, trying to make sure that our stuff is verifiable, doesn't mean we're always going to get it right. The science, again, teaches us you can't prove that something's true. You can only prove that something's false. So our tests will show us concretely when something's broken. If they all pass, we're still taking a chance. We might have not forgotten to write a crucial test or not thought of some aspect of the behavior of our system and it's not tested. That's always going to be the case. So making sure that your failure modes when stuff does go wrong are gentle, and the information flow that comes back to you is going to help inform you and get you quickly back into your nice cycle, your nice feedback cycle, is important. So doing things like smoke testing your deployment is a good way of just verifying that everything still looks sane. So write some automated tests that kind of prod and poke your system, make sure it looks healthy after you've deployed the system into production. And this is kind of the last point here is kind of a direct lift from lean thinking. If anything fails, stop the line. So if a test fails partway through, we don't kind of pause, fix that test, and then carry on from there. We dump that release candidate and say, you're dead, and go back to the start again and fix it again, and we'll put any changes through the whole verification, sequence of verifications once again. So we want to, each step in our verification process, we want to perform once and only once for a successful release candidate. So what does this process look like if this is all working? What does it look like? Well, these sorts of organisations, they tend to be loud and argumentative, and there's lots of conversations going on. People working very closely together. Lots of information around. So information radiators showing people what the state of the builds, the state of their release candidates flowing through the pipeline, that kind of thing. There tends to be lots of sticky notes on walls and stuff like that for agile planning, so that we can kind of shorten the planning cycle. We don't want to have lengthy complex Gantt charts and dependencies and stuff built in. This was a direct steal from somebody's picture. I kind of like automate all of the things. I kind of like that picture. It looks a bit different to a traditional project, but to be honest, it's a lot more fun on the whole. It's a lot more human-centered for much of the creative parts of the process that are really fundamental of software development and design. This is a quote from a Forrester research paper that kind of, this is just an ego thing maybe, but it kind of pleased me when I read it. If agile software development was the opening act to a great performance, continuous delivery is the headliner. This is agile process done right. And the reason why is because we're concentrating on the whole process. We're looking at from end to end, from idea to value. We're trying to make sure that we're going to be doing that as efficiently as possible. And we're applying our skeptical mind, our iterative approach, our experimental approach that we've learned from the scientific method to achieve that. So, what's in a story? This kind of starts at the beginning. The way in which we form our stories is kind of important. The actual structure doesn't matter, but the key idea is that stories shouldn't specify solutions. They should specify the value that you're going to bring. It's important that the business are engaged in the story process so that they understand the value that they're going to get. They know what they're asking for. They're able to prioritize that in an effective way and deliver that into development teams. There are kind of tricks. So I tend to use that as a user. I want some behavior so that I can achieve some benefit. But there are other flavors. There's a great book that's kind of in development at the moment. It's an open source publication from Gojko Adzik, and it's 50 quick ideas for story writing. And it's brilliant. If you know Gojko's work, he's entertaining, funny, and brilliant. And I recommend it. Keep your eye out for that when it comes along. I learnt a lot from the drafts that I've read so far. The stories kind of flow in through the process, and they're kind of the atoms that the rest of the process is built on. When we're thinking about stories, it's what the business are thinking about in terms of priority. It's what the development team are thinking of building. It's what the testers, if you have a separate test team, are going to evaluate against. It's what when we get to the operations end or the release end, it's what we're going to release into production. It's what users will perceive as the changes in the functions of the system. So stories are kind of the kind of grist of the mill. It's important that they flow through, and it's important that they're not kind of techie artifacts, which requirements too often are. Coming up with a functional design for your system is a hard problem. Coming up with a solution for your system is a hard problem. Doing what we, as an industry, we've done way too often, of bunging those together so that we actually describe our requirements in the form of describing the solution, is a doubly hard problem. Why would you want to do that? Specify what the value is, specify what it is that you want to achieve, and then separately, divorced from that, think about how you're going to achieve it. That's a much better way of doing things. The stories kind of pull into the planning and the prediction for the process and so on. It's kind of vital to the way that the process runs. Development is again iterative, fine-grained, and organizations that do this well, it's highly collaborative. As I said before, teams that are employing these sorts of processes tend to be noisy places. They tend to be argumentative places where people are debating ideas and saying, no, that's rubbish, we don't want to do it like this. And there's lots of drawing on whiteboards and stuff like that all of the time going on. Certainly where Steve and I worked at LMAX, we had lots of arguments. but we had, I would say that 95% of the time there was probably a couple of people standing at a whiteboard from the development team at any given point in the day. There's always people kind of discussing and debating ideas and trying to figure out what's going on. This is a lot of fun. This is more efficient, more effective, creates higher quality results, and it's a lot of fun. It's a much nicer environment to work in. Collaborative, so we'll be using our automation and using those tools to be quick and minimize our feedback loops. We'll be doing showcases. This was the best picture of a showcase that I could think of, Steve Jobs showing off an iPhone. We'll be doing showcases to demonstrate our ideas to the business. It's kind of Agile 101, but it's still important to the process. It's still important to glue everybody together and to pull all of the work of all of the people involved in software delivery together into one coherent whole. And that's kind of a key idea too. We're all aiming towards the same goal. Everybody, from the business to the developers, testers, operations people, have the same goal. It's not, I'm done when I've handed it over the wall as a developer, I'm done when I've handed it over the wall to a tester. That's not sufficient. I'm done when my software is in the hand of users producing value, and so is everybody else. So we're all working to the same goal. We're all looking to remove barriers and to make sure that we achieve our goals in that way. So this is, I'm going to whiz through. Can I just have a show of hands? How many people are operating a continuous delivery process now? Cool. How many people have read about it and understand what I'm talking about? How many people, if any, have no clue at all? Good. So I'm going to whiz through this very quickly because I'm sure you've seen lots of presentations like this. So if we're trying to get our software verifiable, we're looking to try and ensure that any change that we make of whatever nature is going to be good when it gets into production, or at least we're going to know if it's bad. So this is based on this picture's based on the pipeline that we developed for the LMAX project that I worked on. So we'd have a pair of developers working together, writing code locally. When they were ready, they'd commit this to the source code repository, and we'd run the commit tests. And the commit tests are called commit tests because it's not just unit tests. This is the collection of tests that will run very quickly and ideally give you a result in under 5 minutes that gives you a high degree of confidence that changes that you've made are going to be successful. So there's going to be mostly unit tests, but other tests too. So if you're using something like Spring, which is not one of my favorite technologies, but you know, one of the nasty things about Spring is that you don't know whether the Spring configuration works until runtime. It's not something you kind of run a test. So write some tests that test that your Spring configuration is going to work and run them as part of this pipeline. That's one of the things that we did. That sort of thing. So what we're trying to do is you're just trying to get early vision of the classic, the common failures that are going to trip you up, whatever they might be. If that all works, if that's successful, if all of those tests pass, then we're going to commit those results to the artifact repository. And remember at the start I said build binaries only once, so we want to make sure that we're going to release the code that we tested through here is the code that will get released if we release into production. This is expensive, so at the moment I'm working on a project where we're building fairly sophisticated deployment pipelines for intractable technologies, so things like stuff for programming solid-state devices and C++ applications, and we're working bloody hard and throwing lots of hardware at trying to get this cycle round fast so that we can get a turnaround very quickly from our commit cycle. It can be hard, but it's worth the investment. That feedback loop dramatically affects the effectiveness of your teams. Once that's the commit stage is passed, the acceptance stage is monitoring the artifact repository. When the acceptance stage comes free, the resources in your acceptance test environment come free. They're going to go and have a look in the artifact repository, and they're going to look for the newest release candidate that's past the commit stage. And they're going to pull that down, deploy it into some test environment, ideally a a lifelike representation of your production environment and run a whole suite of acceptance tests. A common approach, it's not the only approach, but a common approach to doing this in terms of plugging this into the process is when you're writing your stories, define some acceptance criteria so you recognize how you will recognize when the value that the story represents is delivered. And then make it a requirement for your development teams to implement at least one automated test for every one of those requirements. What happens when you do that is that you tend to over-test a bit, but it's an easy way of building up great functional coverage in your testing without thinking too hard and designing too hard about what paths through the software you need to execute. You can kind of have a weeding approach and go back later and kind of rationalize and crunch down some of the common paths through your software to minimize those. But hardware is relatively cheap, so throwing hardware at this works quite well, and parallelizing the build for acceptance testing works very well. At LMAX, we had in the order of about, when I left, we had about 30,000 tests in the commit stage, and we had about somewhere between 15 and 20,000 tests in the acceptance test stage. Those were whole system black box tests, and the whole thing would give us a result in about 40 minutes. Manual testing, if you've got user interface, I talked about how useless we are as human beings at technically complex, boring tasks, and there's not much that I can imagine that falls into that category than manual regression testing. Human beings are the wrong tool for manual regression testing. If you've got human beings doing manual regression testing, you're doing it wrong. Automate that. What human beings are brilliant at is kind of wandering about and discovering things, doing crazy things, being experimental, trying different key combinations, spotting stupid mistakes like you've got white text on a white button so you can't see what to press, or you've got some field that's off the screen and you can't get to it. An automated test will pass for both of those because it can't tell that you can't see it on the screen. A human being will spot that sort of thing instantly. So it's important to use people for what they're good for. Use their intelligence, use their pattern matching, use them to evaluate the usability of the software, those kind of softer things. But use the hard data in terms of, does this pass or fail this test? That's for the machines. Where other aspects of the performance of your system are important, add those as well. So the project that this was based on was we were building a financial exchange. So performance was a critical component. So we had two stages of performance testing. We had component level performance testing where we would test the interactions of our system, any changes to our system for components that we'd identified as being performance critical, and we had whole system performance testing where we would kind of we would have a lifelike productions-like system deployment of our system, and we would run lifelike scenarios through it and kind of evaluate the performance. And both of these would kind of flag interesting kinds of failures and give us useful information, useful feedback. Staging. We used to use this primarily for testing data migration. So as part of the deployment, the software that you deploy isn't the only data aren't the only bits and bytes that are relevant when you deploy your software. The data that builds up with the application is also important, and you've got to keep that, migrate it forward as you have schema changes or whatever else, and testing those and evaluating those in the context of your deployments is important. In our situation, we were low latency, high throughput. Our system of record is largely in memory, so we had to go quite a long way to migrate that in-memory state from one of our exchanges to the new version on every release. And we automated that. We pulled down a copy of the production data and anonymize it, and we'd start up the application, run some smoke tests against it with migrating the data. So part of our deployment scripts would be to migrate the schemas of the data and apply patches and changes to those as part of the deployment. And we'd bring up the application, run the smoke tests against it to see if it worked. And if it worked, it was all okay, ready to go and release into production. And finally, there's the release into production. these kind of arrows going back the other way, they're kind of capturing the metadata. They're capturing the life cycle of what's going on through the life of changes. And if you work in a regulatory environment like I do, auditors and regulators love this stuff. There is no better way of proving that you're complying with their rules. You have a full traceability just by accident. You can't build this stuff without having traceability. You have a full traceability from end to end of all of the changes that have happened, from who came up with the idea, who wrote the code, what tests were run against it, when it was deployed, who manually tested it. All of that stuff is just kind of tracked almost by accident by building a build pipeline like this. The last thing I'll say about the deployment pipeline, it was actually my idea to call it a deployment pipeline, and because I'm a nerd, this isn't because it's a straight line thing like the nice logo from the conference. It's because it reminded me of processor pipelines from in Intel processors, and processor pipelines it's a branch prediction algorithm. So what we're doing here is, as the developers are writing the code, they're going to sit and they're going to wait for the results of the commit tests, and they're going to wait the 5 minutes and not do anything else, really. So if that fails, they're in the best possible place to respond to the failure and to correct it. If it passes, this is where the branch prediction kicks in. They're going to move on to the next task, and they're making the gamble that the commit build is going to catch their common mistakes, and that the rest of this stuff is going to pass. If this all passes, they've won their gamble, and they've managed to do work in parallel with what's gone on here. If something fails here, they've lost their gamble. They're going to have the hiccup of dropping what they're doing, trying to figure out what the breakage is and fixing that, and getting back to getting the build working. So it's a branch prediction algorithm, and that's why it's called a pipeline. I'm going to skip over some of this because I'm getting a little bit slow, behind on time. There's a key idea here is that this works well with small units of change. It's very common to do it has been very common to do large features, write those on a branch or something like that, integrate them at the end, and then find out that your changes didn't work with everybody else's changes. Small units of change are much more effective, and not just small units of change in terms of the commit cycle, small units of change in terms of deployment. This is a way of de-risking deployment. If you're regularly committing small changes into production, your exposure to risk is down because each change is small. If something goes wrong, it's usually easy to step back or to at least understand the nature of the failure if the change is small. If the change is big and complex, you're going to spend a lot of time just trying to figure out what the bloody hell went wrong before you get to fixing it. Okay, so one of the common bits of feedback that I get is, yeah, this is all right for simple web applications, all this continuous delivery stuff, but it doesn't really scale, does it? Well, actually, it does really scale. So Google apply a continuous delivery process. And Google, interestingly, have a single line of code, a single head, a single repo for all of their changes across all of their projects. So if you're working at Google, you commit any change, your build is your change is going to trigger the build and the testing of everything that Google produces. And you're going to get feedback on that very quickly because they've invested phenomenally in the build and test hardware. So they have a single monolithic repository, and they run 60 million builds per year, and that's growing exponentially. There's 100 million lines of code, and all tests are run on every commit. That's 100 million test cases that are executed per day. So if anybody has a project that's bigger than that and thinks continuous delivery doesn't apply, talk to me afterwards, okay? So this is another one of those quotes that I hear from time to time. It's too complex and can't possibly work. So The Amazon build process, Amazon also apply these techniques, and the mean time between deployments for Amazon is 11.6 seconds. That means, so hosts receiving a deployment simultaneously is 10,000. And as a result of that, so many, many small changes, widely spread, as a result of that, they've seen a 75% reduction in outages triggered by deployment, and a 90% reduction in the outage minutes triggered by deployment. So less than 1,000th of deployments cause an outage. This is one of my favorite ones. So the other ones is, but my environment's too complex. You know, I'm dealing with different technology to you. It's, Java's easy. And right, Java, C#, those sorts of languages, Ruby, Python, they make life easier than some other technical approaches. But that doesn't rule out these ideas. Remember what I said, this is grounded in the scientific approach. The scientific method is the best problem-solving technique that humankind has ever invented. We should be applying that to our hard problems, and software development of whatever nature is a hard problem. So taking those fundamentals, applying those, works for other things. So the HP LaserJet firmware team were in a terrible mess. They had a large so this is the firmware for all HP LaserJet printers. And the statistics were pretty poor reading. So in 2008, they spent 10% of their development effort on code integration, 20% on planning, 25% on porting code, 25% on product support, 15% on manual testing, approximately 5% on doing new stuff. So they had thousands of employees working, and 5% of the effort was going on doing new stuff. And they recognized that they had to do something else. And this is kind of interesting to me as well. Again, kind of my science nerdism. This is an example of parallel evolution. So what happened was that they think, let's try and do something that works better. Let's try and be a bit more scientific in our approach. And they independently came up with the ideas of continuous delivery. So the language is all different, the way that they describe it. But they did it without reading anything else from outside, because there wasn't anything else at the time when they started that described this. It wasn't until afterwards, when they'd already made the change, gone through the transition, that they started reading stuff, and things like my book came out, and the conversation started, that they realized that there were people sharing the experience. But they kind of did this independently. So by 2011, they spent 2% on continuous integration, 5% on planning, 15% architectural integrity, 10% unified support, and that left them with 40% of effort on innovation. It's a dramatic change in the amount of effort that they could spend doing what's really valuable to the company. So overall, their development costs were reduced by 40%, programs under development increased by 140%, development costs per program down by 70, resources now driving innovation increased by 5 times. These are transformative changes into a business. This is not just about a software development team doing some nerdy thing in a corner that makes them have more fun and be more effective. This changes the way the business works. The quality of their products have gone up dramatically, is what they say. All of this is detailed in quite an interesting and good book. It's an easy read. It's a nice, good read as well, called Large Scale Agile Development. So what sorts of companies perform practice continuous delivery? Well, there's lots of the big names. Some of them that may surprise you. So SAP, for example, have been blogging and presenting on applying the techniques of continuous delivery in segments of the organization, but again, they're talking about transformative experiences. This is a way of developing software better. Many of the names, if your head's been in this space for a while, will be familiar to you. Nokia, Flickr, the New York Stock Exchange, New York Times, Netflix. And some of these organisations have great stories to tell about their journey. But this isn't just for the big web monsters. This is for any kind of software development. If it's the scientific method, if we're talking about establishing our feedback loops and iterating and applying the skeptical mind, not making guesses, trying to make our process and our software verifiable, that's going to work for any approach. That's our best problem-solving technique. So it's going to work for any kind of software development. These are just some of the early adopters and some of the people that have really been talking about the advantages that they've seen. That's all. I have a very short amount of time left. I've talked a little bit too long for questions, but I'm happy to take any questions. And I've got 15 minutes. Oh, great. Okay, I am on time. So lots of time for questions then.
I've got to sell to my team using an artifact repository rather than checking out tags from the source control. Can you help me do that?
I think I can tell you some war stories. So one of the war stories is I worked on a project at Dixon's. I wrote the point of sale system for Dixon's, and we had a we had a variety of, it was kind of a nice model. It was, nowadays you might even call it a microservice model in some ways. It was a while ago now, but maybe that's a stretch. But you know, we had a variety of servers in production doing different things. And we had this one, and we had this production outage, and we had this one server that was just flaky, that just kept causing problems, and we couldn't work out what it was. And we did, you know, we'd been doing some of this. This was one of the projects that was kind of laid some of the seeds for the ideas of continuous delivery. So we were doing multi-stage testing. We were doing all sorts of different verifications as we went. But we weren't kind of doing the infrastructure as code thing. We weren't kind of really we were compiling to a target. We were, you know, doing that sort of release strategy. We hadn't fully automated the deployment of these in that sense for the central servers. And so we got desperate, and we kind of did an audit of the system, and the only thing that we could find that was any different was that there was one third-party library that was a different rev, a minor rev different. It was for an IBM, part of Java. We were using IBM's Java at the time. And there was one library that was a minor rev different, and when we changed that, it fixed the problem. So I want to be sure that what I deploy into production is the stuff that I tested. The artifact repository is a convenient way of doing that thing, and it's an easy thing to do. So the artifact repository gives you the ability to test all of the stuff, the third-party libraries, the language, the version of the database, everything all together, and kind of make sure that the thing that you've tested and verified is the thing that will be released into production. That is it's a surprisingly common source of errors. And so the other thing that it kind of gives you is it kind of gives you, you know, as my diagram with the kind of circle around it showing the process, it kind of gives you a central point to collect the metadata. So, you know, without that, there's not an obvious place that's kind of, to my mind, that kind of sits to give you that thing. So this idea of kind of creating the release candidate and that being a concrete thing, it's the deployable units that you will release into production if that release candidate is successful. You kind of, that's the thing that you store. You kind of decorate it with metadata as it goes through its evaluation process, and you know that gives you the kind of traceability. So having said all of that, it might not, the argument might not work. But that's where the value is for me. It's one way. It's a way of eliminating one source of common errors. Different version of compilers, different versions of libraries, all of those sorts of things. If you're compiling to a target, you know, there's lots of ways in which errors can creep into that. Things that you would have caught with a test earlier in the cycle, that kind of thing.
It's also about the resilience if source controls down and missing cache because it's faster than reload.
Yes, that's a good point. It gives you a quicker path to release.
What sort of things count as a sort of artifact repository? Because we don't use Nexus or anything. We just say that there's artifacts and, like, you know, Jenkins jobs. Does that?
Yeah, I think so. I think anything you think of. So a lot of the stuff around tooling, I started doing this stuff before there was much on the marketplace. So my experience and most of the projects that I've worked on, we've kind of cobbled together our own tools, and that included the artifact repository. So for most of the artifact repositories that I use, it's kind of really just a fancy name for an area of the disk and a kind of organizing mechanism, just date-based folder names, that kind of thing. And years ago I wrote some Ant targets that would just kind of manage an area of the disk and kind of treat it as a binary repository, keeping a little XML file as an index to capture the metadata, that kind of thing. These days, my current project, we're using Artifactory because it's off the shelf. It gives us lots of nice properties. You can treat it as a Yum repository or an RPM repository and lots of other things. So it doesn't have to be anything fancy, but there are now tools that open source tools that are perfectly good and adequate, and I tend to use those now.
Anyone assuming that the old X pipeline was built with state-of-the-art tooling misguided. The tooling was cruise control 2.8.1. I remember us being very excited about 2.8.2, and it was a couple of Ant scripts and a shared disk. That was it. It was nothing. The important part was that everyone was aligned. Everyone went to it.
Yes. One of the things that's kind of interesting is that this stuff is taking up. I didn't really say this in my talk. I said early on, I think that there's room for hope. I think that we're in the midst of a sea change. I think that the agile development and continuous delivery has kind of moved the game on, and that companies are recognizing the fact that this is a competitive advantage. They can be more effective as companies. They get more experimental at the business level by adopting these techniques. They get what they always wanted, which was to be able to have an idea, get it into the hands of users quickly, if they apply these sorts of things. And there are lots and lots of people that are talking about this. I think this is going to be, I've kind of been slightly misquoted a few times on saying this, but I'll try and explain what I mean. I think that the future of software development will be more this shape than it will be waterfall shaped. Not because I'm vain and egotistical and I think my idea is brilliant, but it's because it's the application of the scientific method, and that's our best way of solving problems. So in the future, 10, 20, 30, 40, 50 years' time, people, as long as people are still developing software and computers aren't developing it, people will be applying those techniques because that's how we make progress the best. That's how we solve problems the best. And so I think it's an important change, and that there's kind of this sea change that's going on now. It's now I can remember being a consultant around agile techniques and stuff like that, where our first step of our engagement was to try and convince people that we weren't all crazy nutters that were going in selling these stupid ideas that some wacky bloke in California had invented. It was just seen as bizarre and out of left field. Now it's seen as mainstream. It's seen as the norm. Even the government are publishing stuff about, agile and continuous delivery strategies on their, for their software projects. This is, we're in the midst of a change. We're kind of moving on in terms of the thinking, and I think it's important to apply these, the fundamental ideas, and as a result of that change, the reason that I started on this rambling description is that I'm getting approached by lots of vendors these days for various products because they're seeing that as a good way of selling their products and a good way of evolving their products to kind of help out. And that doesn't mean that's a bad thing, it's a good thing, but it's not primarily about products. The ideas are much more important. As Steve says, that the projects, nearly all of the projects that I've worked on, the infrastructure that we built was kind of cobbled together with bits and pieces of tools and bits of scripting, and that works absolutely fine. There's nothing at all wrong with that. Some of the products are more effective, more polished than that, and they can give you a leg up, but it's not a product kind of thing, it's an idea thing. It's the ideas, the philosophy is much more important than the technology here.
So on the cultural side of things, you talked a bit about sort of agile culture and stuff in there. Is this really going to scale across cultures that have, say, a greater power distance, much bigger gap between what the manager wants and what the people at this level, and just completely different attitudes towards questioning your boss, questioning somebody who's older than you? Is there anything to sort of say that this is going to work in different cultures, not always goes 50?
Yeah, I think that there are cultural differences that make it tougher to adopt some of these principles. But fundamentally, I do think there's something fundamental about this, the way that it works. And so, you know, I think that it is effective. So I think that there are cultures, as you described, where people, it's going to be a bigger jump for them to get to this. But my experience of working with people from some of those cultures has been, you know, it might take them a little while to get over that hump, but it still works for them, and they still love it once they get there. So I used to be a consultant for ThoughtWorks, and ThoughtWorks has offices around the world, including in some countries that kind of have the sorts of cultures that you're describing. And some of the people in some of those offices were amongst the best in the company at some of this stuff. So I think the cultural barriers can make the transition difficult, but I don't think it prevents the adoption of the ideas. And I think it's just a matter of, you still need to be collaborative. You still need, you need to get to that level of empowerment. And to be honest, that's probably, in different ways, that's probably as hard for a company that's just used to working in a procedural waterfall kind of way, command and control kind of approach, as it is for somebody from a different social culture. So I think the cultural change is very difficult, and there are differences in where it's difficult, but it's still difficult.
Hi. One thing you brought up that was quite disappointing was the lack of kind of scientific application to the standards of quality, how quality impacts this whole thing. And there are really no studies in that area, no numbers produced yet or anything.
I haven't come across anything, and it's something that's very close to my heart. That maybe there are, but I haven't come across anything myself. The people that I've looked for some of those numbers, they don't really say anything. And I'm a complete believer, but I don't have any evidence that I can point to.
You talk about sort of policies, regulated environments. Have you had an experience sort of squaring, if you like, breaking down organisational silos with the separation of duties?
Yes, so that can be a problem. So LMAX is a good example. So LMAX is a financial exchange where we were, and it was a retail financial exchange. Our business model was to give anybody on the internet the ability to trade in financial instruments. And so we were a difficult organisational quantity for what was then the FSA. And we were going through the process of accreditation while we were building the software as well. And that's a barrier. That's a difficult. There is no simple answer to that. So what we're describing is there's the separation in certain organisations. There's a regulatory need to separate access to production environments from access to development environments, so that you can't perform fraud or whatever. We went through some hurdles to try and mitigate the impact of those regulations. So we did do what everybody says is an anti-pattern, and we formed, for a variety of reasons, we formed a DevOps team, and we rotated people through the DevOps team. And while people were in the DevOps team, we had to change their privileges. So people that were part of the DevOps team had greater access to production environments and less access to the development environments, for example. But the real answer is nobody should be touching production. It should be automated. Operators shouldn't be going in and tinkering in production either. All of that stuff should be automated. And there should be no need for human beings to go in and tinker manually in production environments. And that's doubly important as we're in a world of kind of growing server farms and running stuff in the cloud, where people's deployed environment is typically hundreds and thousands of server instances. So it can be tricky, and I think you have to be pragmatic and find ways of working around it, but I think it's doable. Excuse me, somebody at the back.
You said that nobody should touch the production actual. Is that going for the database as well?
Yep. So I think database deployments. I think it should be the deployment of the database, the modification of schema and stuff should be automated. that sort of thing. I think it's useful to allow some people to do ad hoc queries if they really know what they're doing, but I don't think anybody should be writing to the database in production.
Non-production copy.
Yes, yes, absolutely. So you just cluster it and you look in a non-production copy. That's one of the techniques that we did.
You had somebody crash a database, like completely physically crash a database with a select statement.
Yes, it's easily done. Sorry, one more.
How would you go about changing a culture where you need a 3-day leave limit so you can actually change the
Try. One of my ex-colleagues, Dan North, used to talk about, he had a pattern, a consultancy pattern, and the pattern was that you followed the resistance, so that you would try and, so somebody says you've got this thing that gets in the way, this 3-day window gets in the way, and say, well, why is that? And well, this bloke over here says that you're not supposed to do that. So you go to that bloke and he says, oh, that's a rule that's enforced by this woman over here who's you know, in this department. So you go to them and you follow up the chain and you find out that actually nobody really needs that, or you argue the case and you're trying to make the change. Fundamentally, this is about trying to be as rational as we can. And so those organisational barriers, processes, policies that get in the way, you've got to find a way of breaking them down. And a lot of that is to do with the silly human things of just being irritating in the right times and nagging people to do the right things.
Started raising a change ticket every day for 3 days in advance, called everyone hot fix, they soon stopped asking.
Okay, my time is up. Thank you very much for your time. I hope you have a great conference.